binomial expansion, and we are going to expand binomials. Okay? So one example of what we're going to do is we're going to expand a binomial like a plus b to the 0 power. What's a plus b to the 0 power? 1. I'm going to write that far over here. We're going to start creating a pattern that actually references sequences from things that we've been doing. Okay? So then we're going to do a plus b to the first power, which is a plus b. You know, I'm going to do this in red and this in. Okay? Then we're going to do a plus b to the second power. Don't say a squared plus b squared, please. It's a squared plus 2ab plus b squared. Okay. A pattern's actually developing. You can kind of notice it. You've actually probably seen this pattern as we're doing it. So let's go a little bit crazy. Let's go a plus b to the third power. Oops, to the third power. Okay? To do this, I'm going to write a bunch of scratch work down below, okay? First, we know that that's a plus b to the second power times another a plus b, right? So a plus b to the third power, I'm going to show some scratch work here, and then I'm going to turn around and erase it, is going to be a plus b squared times a plus b, right? A plus b squared we just did was a squared plus 2ab plus b squared times a plus b, correct? So let's multiply that out and simplify as needed. Essentially what we're doing right now is we're just creating a pattern, and after we create the pattern, then we're going to respond based and do problems based off of that pattern that we're creating. So let's multiply this out. Go ahead and multiply that out and simplify it and see what it is. So after you expand it, you get a to the third plus 3a squared b plus 3ab squared plus b to the third. And I'm going to write the coefficients in red again. Let's do it one more time, okay? And then we'll talk about the pattern that's created. And we'll ask you guys what you see. A plus b to the fourth. A plus b to the fourth is a plus b to the third times another a plus b. So go ahead and multiply that mess out. Did y'all get that? There it is to... so there it is to the fourth power. Okay. What I want you to do now is I want you to take a look at all of those, and I want you to find a pattern, or 8, because there's a lot of different patterns that are associated with what we're doing right now. Okay, so I want you to look up here on this set, and I want you to find the patterns associated with that set. Conversation that we had, you guys noticed that there were some patterns that are all ones here. These two added together give you 2. You know, these two things get added together give you 3. These two things added together give you 6, and so on and so forth. So we can continue to write the different rows of Pascal's triangle as we go through just by working through it. We can also then expand binomials based off of this, or based off a version of Pascal's triangle to expand them. So what we could do, this, for instance, this is the first row. Oh, sorry. This is, we call this the 0 row because it's to the 0 power. This is to the first power, the second power, the third power, the fourth power, and then we can keep continuing that as we go through. Okay. So if we're just focusing on the coefficients that we're going to wind up having, for the fifth row or the fifth power, we're going to turn around and have 1, 5, right? Keep writing it. Keep writing. Just keep filling out Pascal's triangle. Do 2 more rows, okay? Or a total of 3 rows. Do to the 5th power, do to the 6th power, and do the 7th power, because in the end I want us to be able to expand a plus b to the 7th power without doing all the work that we had to do down here. Okay? So keep going and expand Pascal's triangle. So right now 4 plus 6, that's going to be 10 there. Then we go 4 plus 6 again, it's going to be 10. 4 plus 1 is going to be 5, and then it's 1 at the end. Okay. And we keep going. We got 2 more rows to do until we get to the 7th row. 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10, 20. 10 plus 5, 15. 5 plus 1, 6, and 1. And we can keep going. 1, 7, 21, 35, 35, 21, 7, 1. And that winds up being our 7th row. From this, what we can do is we can turn around and we can start writing in the variables or the terms. Okay, it's the 7th row, starting at the 0 row. This is going to be a to the 7th then. It's going to be a to the 6th, a to the 5th, a to the 4th, a to the 3rd, a squared, a to the 1st, and a to the 0, so I'm just not going to write it. Then you can flip it up again with b's. B to the 0, so I'm not going to write it. B to the 1st, B to the 2nd, and we're going up now. B to the 3rd, B to the 4th, B to the 5th, B to the 6th, and squeeze that in, B to the 7th. Okay? And all these numbers are positive. I'm going to scroll down for you. All these numbers wind up being positive, so it's all adding. So it's add here, add here, add here, add here, add here, and add here. And I'm going to get rid of the ones because we don't write those if we can avoid it. Okay, and this, in a very colorful fashion, would be the expansion of a plus b to the 7th power. Wow, that's exciting, isn't it? That's cool. It's kind of mixed up in a very funky number sequence, okay, that we can use called Pascal's triangle. Let's do another expansion. Instead of just a plus b, let's mix it up a little bit, which is going to make it a little bit more difficult. Let's do something like 2x plus 3 to the, let's just do to the 5th power. No need to get too crazy. Okay. What we know is that it's going to follow the row. It's actually the 6th row in Pascal's triangle, but if we start counting at 0, it's the 5th row. The row that represents to the 5th power. When you do it, I would highly recommend just to write down what that row of Pascal's triangle actually is, and then fill in the variable separate. Okay? So if I ask you to expand using Pascal's triangle, if I ask you to do that, and actually there's one question on the test that says exactly that, expand using Pascal's triangle. I would draw Pascal's triangle until you get to the point where you're at the row that you need. Okay, one way that you know you're at the right row is start at 0 and count down 0, 1, 2, 3, 4, 5, 6. Or just like one of the patterns you guys noticed, 5, there needs to be one more than that as far as terms go. One more. It's the 4th row to the 4th power. There needs to be. You need to write out 5 numbers to get there. So anyways, so then start filling in the expressions into each one of the corresponding locations. So the next one, this is going to be 2x to the 5th. And then the next is going to go 2x to the 4th. All to the 4th power. Then the next one is going to be 2x to the 3rd, 2x squared, 2x, and then 2x to 0, but I'm just not going to write it. We can follow the same pattern with 3's, right? We start at 3 to the 0, then 3 to the 1st, then 3 to the 2nd, then 3 to the 3rd, then 3 to the 4th, then 3 to the 5th. and we add each consecutive one. So then the first one winds up becoming 2 to the 5th times x to the 5th, so it's 32x to the 5th plus, you get 5 times 2 to the 4th times 3, which is going to be 240, and it's x to the 4th. Okay. Stop me if you have any questions as we're going along. Plus 10 times 2 to the 3rd power times 3 to the 2nd, right? 720 x to the 3rd plus 10 times 2 to the 2nd power times 3 to the 3rd power, 1080 x squared plus, keep going with the pattern, 5 times 2 times 3 to the 4th, 810 x, and then plus 3 to the 5th times 1, so it's just 3 to the 5th, 243. Emphasize the negatives here. If you do 2x minus 3, you know what, let's change that, minus 5 to the 3rd power to expand it. Find that row of Pascal's triangle. So it's going to be the row 1, 3, 3, 1 are going to be the coefficients. 1, 3, 3, 1, and then start putting the expressions in to the corresponding powers. So 2x to the 3rd, 2x squared, 2x, and then 2x to the 0 power. And then we reverse it for negative 5. We put in negative 5 though. Okay, this becomes negative 5 to the 0, negative 5 to the 1st, negative 5 to the 2nd, and then negative 5 to the 3rd. Add up all those separate terms, and we'll simplify. 2x to the 3rd is going to be 8x to the 3rd plus 3 times 2 squared times negative 5 to the 1st, which is just going to be negative 5. So you get, it's actually no longer plus, it's negative 60x squared. Okay. Then you get 3 times 2 times negative 5 to the 2nd power. Which is going to be positive 150 x, and then negative 5 to the 3rd power, which is going to be minus 125. Any questions, guys?